Imagine standing on a distant world, the sky tinted in shades never seen on Earth. A dim red sun hangs low on the horizon, casting long shadows over alien oceans that stretch endlessly. The air is thick with unknown gases, and beneath the surface, something stirs, something alive. It might sound like the premise of a science fiction novel, but what if it's real? What if, at this very moment, alien life is thriving somewhere beyond our reach? For centuries, humanity has gazed at the stars wondering if we are alone. But today we stand on the brink of answering that question. Scientists are closer than ever to finding definitive proof that life exists beyond Earth, and the evidence is mounting in ways we never imagined. For much of human history, the idea of extraterrestrial life was purely speculative. Ancient civilizations looked at the night sky and imagined gods or spirits inhabiting distant celestial bodies. Later, as science advanced, astronomers began to consider the possibility of life beyond Earth. But without tangible proof, the search remained a philosophical debate rather than a scientific endeavor. That changed in the 20th century with the advent of powerful telescopes and space exploration. We sent probes to Mars, scanned radio signals from deep space, and analyzed meteorites for traces of alien biology. Yet, despite decades of searching, we never found direct evidence until now. A revolution is unfolding in the field of astrobiology. Scientists are no longer just theorizing about alien life. They are actively detecting signals, scanning exoplanets, and uncovering clues hidden within our own solar system. One of the most groundbreaking advancements comes from the James Webb Space Telescope, a marvel of modern engineering designed to peer into the atmospheres of distant planets with unprecedented detail. This telescope is equipped with powerful infrared sensors that can analyze the chemical compositions of planets orbiting other stars. And what it has found is nothing short of astonishing. Consider the case of K2-18b, an exoplanet located approximately 124 light-years away in the constellation Leo. This super-Earth orbits within the habitable zone of its star, meaning it is at just the right distance where liquid water could exist, a key ingredient for life as we know it. But what truly stunned scientists was the detection of a molecule called dimethyl sulfide, or DMS, in its atmosphere. Here on Earth, DMS is produced almost exclusively by biological organisms, primarily by marine plankton. The implications of this discovery are profound. If this molecule is indeed a product of biological activity, it would mark the first confirmed detection of alien life. However, scientists remain cautious. Further observations are needed to rule out non-biological explanations, but the very fact that we are now identifying potential biosignatures in exoplanetary atmospheres is a monumental step forward. Yet, the search for life isn't confined to distant star systems. In fact, some of the most promising candidates for extraterrestrial organisms lie much closer to home, right here in our own solar system. One of the most intriguing places is Europa, a moon of Jupiter with a thick icy shell. But beneath that ice, something incredible is hidden, a vast global ocean containing more water than all of Earth's oceans combined. What makes Europa particularly exciting is the presence of tidal heating, a process where gravitational interactions with Jupiter generate internal heat, preventing the ocean from freezing solid. Scientists believe this ocean could host hydrothermal vents, deep-sea environments similar to those found on Earth, where life thrives despite the lack of sunlight. These vents on our planet are home to extremophiles, organisms that survive in boiling water, feeding on the minerals spewed from the seafloor. If similar conditions exist on Europa, life could very well exist there too. NASA's upcoming Europa Clipper mission aims to investigate this possibility. Scheduled for launch in the coming years, this spacecraft will orbit Jupiter and make dozens of close flybys of Europa, analyzing its icy crust and searching for organic compounds. Even more exciting, Europa is known to release plumes of water, vapor into space, plumes that may contain chemical signatures of life from the subsurface ocean. If the Clipper can sample these plumes, we might get our first direct evidence of alien biology. But Europa isn't the only moon hiding secrets beneath its surface. Saturn's moon Enceladus has captivated scientists ever since the Cassini spacecraft discovered its dramatic water plumes erupting into space. Unlike Europa, where the ice shell is thick and difficult to penetrate, Enceladus continuously spews material from its subsurface ocean, allowing scientists to sample its composition without needing to drill through miles of ice. Cassini's instruments detected a variety of organic molecules in these plumes, including complex carbon-based compounds that are essential for life. Even more intriguing, some of these molecules suggest the presence of hydrothermal activity on the ocean floor, similar to the conditions that gave rise to life on Earth. This raises a fascinating possibility. Could life already exist in these alien oceans, waiting to be discovered? If microbes or even more complex organisms are swimming in the dark depths of Europa or Enceladus, they could provide the first definitive proof that life isn't unique to Earth. Future missions, such as NASA's Dragonfly drone, will also explore Titan, Saturn's largest moon, which has liquid methane lakes and a thick atmosphere rich in organic chemistry. While Titan's conditions are vastly different from Earth's, some scientists speculate that exotic life forms could thrive in its extreme environment. With each new discovery, the boundaries of our understanding are being pushed further. The search for extraterrestrial life has transitioned from hopeful speculation to a data-driven, targeted investigation. We now have the technology, the missions, and the scientific expertise to detect life beyond Earth. And as the evidence continues to build, the question isn't just whether we will find life, it's how soon we'll make the breakthrough that changes everything. The search for alien life is no longer limited to peering through telescopes or sending probes to distant worlds. Scientists are developing innovative techniques to detect even the faintest hints of extraterrestrial biology, and the results are becoming harder to ignore. Across multiple disciplines, astronomy, chemistry, and planetary science, researchers are finding mounting evidence that life beyond Earth is not just possible but perhaps even likely. One of the most exciting frontiers in this quest is the study of biosignatures, chemical indicators of life that can be detected in the atmospheres of distant planets. The James Webb Space Telescope, JWST, is revolutionizing this field, allowing astronomers to analyze exoplanet atmospheres with unprecedented precision. By studying the way starlight filters through a planet's atmosphere, JWST can determine the composition of gases present. If certain combinations of gases, such as oxygen, methane, and carbon dioxide, appear together in a stable equilibrium, they could indicate biological activity. On Earth, these gases are produced by plants, animals, and microbes, so their presence on an exoplanet could be a sign that life is thriving there as well. One particularly intriguing exoplanet is TRAPPIST-1e, one of 7 Earth-sized planets, orbiting a cool red dwarf star just 40 light-years away. 3 of these planets lie within the star's habitable zone, where liquid water could exist. JWST is now studying their atmospheres in search of biosignatures. While early results are still inconclusive, the discovery of key atmospheric molecules could bring us closer than ever to answering the age-old question, are we alone? But even as we push the boundaries of exoplanet research, we must also consider a different kind of signature, one that isn't biological but technological. If alien civilizations exist, they may be emitting signals or even building megastructures that we could detect. This is the realm of technosignatures, a field of study that looks for artificial signals or anomalies that suggest an intelligent origin. One famous example is the WOW signal, a mysterious radio burst detected in 1977 that bore the hallmarks of an artificial transmission. Although it was never detected again, it remains one of the strongest candidates for an extraterrestrial radio signal. In recent years, the Breakthrough Listen project, funded by billionaire Yuri Milner, has been scanning the skies using some of the world's most powerful radio telescopes. This initiative has already identified several unusual signals, though none have been confirmed as originating from an intelligent source. However, the rapid advancement of artificial intelligence and machine learning is making it easier to analyze vast amounts of radio data. increasing our chances of detecting something truly extraordinary. Beyond radio signals, another potential technosignature is the presence of Dyson spheres, hypothetical megastructures that an advanced civilization might build around a star to harness its energy. While no direct evidence of such structures has been found, astronomers have observed stars with unexplained brightness fluctuations, leading to speculation that they could be partially surrounded by alien-built structures. One such star, known as Tabby's star, exhibited irregular dimming that some scientists initially suggested could be caused by a Dyson swarm. Though natural explanations like dust clouds are more likely, the possibility of artificial megastructures remains an open question. Meanwhile, within our own solar system, astrobiologists are exploring a different kind of evidence: ancient and fossilized life. If Mars or Venus once had habitable conditions, could remnants of past life still be buried beneath their surfaces? NASA's Perseverance rover is currently scouring the Martian surface for signs of ancient microbial life, collecting rock samples that will eventually be returned to Earth for analysis. The Jezero crater, where the rover is operating, was once home to a vast lake and river delta, a prime location for preserving microbial fossils. Interestingly, recent discoveries have suggested that Mars may still have subsurface liquid water, particularly beneath its polar ice caps. If microbial life exists deep underground, shielded from the harsh surface radiation, it could be thriving in hidden pockets of water. Future missions, such as the European Space Agency's Rosalind Franklin rover, aim to drill beneath the surface, to search for signs of life that might be hiding in the Martian soil. But Mars isn't the only planetary body in our solar system that might hold the secrets to life. Venus, long thought to be a hellish, uninhabitable world, recently made headlines when astronomers detected phosphine gas in its upper atmosphere. On Earth, phosphine is produced by microbes in oxygen-free environments, leading scientists to speculate that microbial life could exist in the temperate cloud layers of Venus. While this discovery remains controversial, it has reignited interest in exploring our neighboring planet. NASA and other space agencies are now planning missions to Venus to investigate its atmosphere and determine whether life could be lurking in its clouds. As we explore these possibilities, it's becoming increasingly clear that life in the universe may not be as rare as we once thought. In fact, some scientists believe that given the sheer number of planets in the cosmos, life should be expected rather than seen as an anomaly. With an estimated 100 billion stars in our Milky Way, galaxy alone, and potentially trillions of planets, the idea that Earth is the only world with life seems statistically improbable. Even if only a tiny fraction of planets develop life, there could still be millions of inhabited worlds. The implications of finding alien life, whether microbial or intelligent, are staggering. It would redefine our understanding of biology, evolution, and even our place in the universe. If we discover microbial life on Mars or Europa, it would suggest that life can emerge wherever conditions are right, making the universe teeming with biological diversity. On the other hand, if we detect signals from an advanced civilization, it would mean that we are not the only intelligent beings in the cosmos, a realization that could change everything about how we see ourselves. With each passing year, our tools and techniques for detecting extraterrestrial life become more sophisticated. The search is no longer just a dream of science fiction. It is a real methodical pursuit driven by cutting-edge technology. We are scanning the skies, exploring alien oceans, and peering into the atmospheres of distant worlds. And the deeper we look, the more likely it seems that we are on the verge of a monumental discovery, one that could finally answer the question that has haunted humanity for centuries. The search for alien life has never been more promising, but it also raises profound questions, some of which we may not be fully prepared to answer. If we do discover extraterrestrial organisms, whether microscopic life on Mars or an advanced civilization transmitting radio signals from another star system, how will humanity react? What would it mean for our place in the universe, our philosophies, and even our religions? And perhaps the most unsettling question of all, if alien life is out there, why haven't we found undeniable proof yet? One possibility is that life is indeed abundant in the universe, but most of it is microbial. After all, for most of Earth's history, life existed only in simple, microscopic forms. If the same is true elsewhere, then our galaxy may be teeming with bacteria, archaea, and other primitive organisms, yet lacking complex, intelligent civilizations. This idea aligns with what astrobiologists call the Great Filter hypothesis, the notion that while simple life may emerge easily, the jump to complex, intelligent life might be extremely rare or even nearly impossible. But there's another, more unsettling theory. What if intelligent civilizations do emerge, only to destroy themselves before they can make contact? This scenario, often referred to as the self-destruction hypothesis, suggests that technological advancement inevitably leads to existential threats, whether through nuclear war, environmental collapse, or artificial intelligence spiraling out of control. If this is true, then the reason we haven't heard from alien civilizations could be that they have already wiped themselves out before they could expand beyond their home planets. However, there is still another perspective, one that suggests intelligent extraterrestrials may already be aware of us, but are deliberately avoiding contact. This concept, known as the zoo hypothesis, proposes that advanced alien civilizations observe us from afar, much like scientists watching animals in a nature reserve. If humanity is still in its early stages of development, they may be waiting for us to reach a certain level of technological or moral maturity before making their presence known. Alternatively, they could be enforcing a kind of galactic quarantine, preventing civilizations from interfering with one another until they are ready for interstellar interaction. Then there's the possibility that we simply haven't been looking in the right places or using the right methods. Our current technology may be incapable of detecting the kinds of signals that intelligent aliens use to communicate. If a civilization is millions of years ahead of us, they might have long abandoned radio waves and be using something far more advanced, perhaps quantum communication or even methods we can't yet comprehend. But despite these uncertainties, one thing is clear: we are now closer than ever to uncovering the truth. The next few decades could bring discoveries that redefine everything we thought we knew about life and the universe. Future missions to Europa, Enceladus, and Titan could reveal hidden biospheres beneath layers of ice. New space telescopes, like NASA's upcoming Habitable Worlds Observatory, will have even greater sensitivity for detecting exoplanet atmospheres, possibly revealing direct evidence of alien biology. And the increasing use of artificial intelligence in data analysis could help us sift through cosmic noise to find a signal that has been hiding in plain sight. Even within our own lifetimes, we may witness the moment when humanity confirms the key existence of alien life. Will it be the discovery of microbial fossils on Mars, a chemical signature in an exoplanet's atmosphere, or perhaps a message from an intelligent civilization that has been reaching out, waiting for us to listen? No matter what the answer turns out to be, the search itself is reshaping how we see our place in the cosmos. For centuries, we have gazed at the stars, wondering if we were alone. Now, we stand on the edge of discovery, with the tools and knowledge to finally uncover the truth. If life exists beyond Earth, then the universe is not just a vast, empty expanse. It is alive, filled with the echoes of countless worlds, each with their own stories to tell. And so as we continue our search, we must ask ourselves, when we do find alien life, how will we respond? Will we embrace the knowledge, seeking to learn and grow from what we discover? Or will we let fear and uncertainty hold us back? One thing is certain: humanity is no longer just a species confined to a single planet. We are explorers, seekers of truth, and the universe is our canvas. So what do you think? Are we truly on the verge of discovering alien life? And if we do, how will it change everything we know about ourselves? Let me know your thoughts in the comments. If you enjoyed this deep dive into the search for extraterrestrial life, make sure to like, share, and subscribe to the channel for more mind-expanding content. The universe is vast, and our journey is just beginning. Stay curious, and I'll see you in the next one.